look at this. We'll look at this again. So here's four quadratic equations. The first one, x squared minus 2x minus 3. Using the quadratic formula, and this is all on your notes, they highlight that you get the square root of a positive number. Okay? And if this number inside is a perfect square, like 16 is, then it will simplify nicely to nice numbers, which means this one could have been factored. But we're going to, off to the side, is beside this one, we're going to write two rational roots. And we're going to introduce, even though they introduce it not until the next page, I'm going to introduce it already. A new word. We call in the quadratic formula the b squared minus 4ac part. That's the part that's inside the square root. Okay? But I just can move that aside because the discriminant is just the number inside the square root. It doesn't include the square root. But the number that's inside the square root is positive. And does it make sense that if you have plus or minus a positive number, you will get two answers? So this is the big idea of this section, is we're looking at when do we have two answers, when do we have one answer, when do we have zero answers. And if you plus or minus a positive number, you will always get two answers. If that positive number also happens to be a perfect square, like in this case it was the square root of 16, your square root would go away, and you will have rational answers. It also means that this one could have been factored. And that would probably be a much faster way of solving this question, right? Because I could have just gone bracket, 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 bracket equals 0, x and x, two numbers that equal 3, so that my outside and inside give me 2. I'm going to go 3 and 1. I need negative 2, so the inside negative 3x, outside plus x. Double check it, and sure enough, it works. You could have then split it here and said, oh, so x equals 3, x equals minus 1. And factoring is much faster than the quadratic formula. But factoring doesn't always work, as we can see with example 2. No, this one can't. Oh, it looks like it should be factored. But when we plug everything in, inside of our square root here, we get root 8. So beside this one, we can write two irrational roots the discriminant, and again, we're going to write out the definition of this discriminant every single time. The discriminant, that's the b squared minus 4ac, is positive again. So this idea of it being positive, that tells us the number of two roots. The irrational or rational, in this case, it's not a perfect square. Last time it was a perfect square, this time it's not a perfect square. You still get two roots. One of them was two rational roots, this one two irrational roots. Of course, you'd have to simplify it, right? But if you have two irrational roots, you can't solve it by factoring. You would have to use either the quadratic formula or completing the square. looking at this equation, I might say, you know what, I think completing the square would be better than the quadratic formula. Because this one with the quadratic formula, you had to simplify the root 8 to get 2 root 2. Then you had to simplify the fraction because each term was divisible by 2. So there's a little bit of work for simplification in the quadratic formula. If you completed the square on this one, you would avoid that simplification part. X squared minus 2x plus 1. This one, you get the square root of 0. So we're going to write off to the side that this has one root and that the discriminant, and every time you write this, your brain should be like, I'm starting to remember what the discriminant is. That's the part inside the square root, is 0. If the discriminant is 0, things simplify. And you could have factored this one. X and x, 1 and 1, both minus. And if you solved it with factoring, you would get x equals 1 twice. In grade 12, we will say that x equals 1 is a root of multiplicity 2 because it shows up twice in the answers. And that's why I guess sometimes they say this has 2 equal roots in grade 11. And finally, everybody's favorite, you're doing your work, and inside you get a negative, so you can just stop and say there's no solutions. Again, the discriminant. Rewrite the definition. That's the b squared minus 4ac part. Is negative. So if we just analyze that part of the equation, we can tell how many answers we're going to have, right? We can tell if it can be factored or not quicker if we analyze that. So this is something that can help us. So on the next page, they have the actual definition, so it's nice to highlight words like this. B squared minus 4ac is called the discriminant. I don't know where they came up with that word. Maybe because it's discriminatory. It's the thing that tells you which one it is. And I don't know if that discriminates, or I don't even know if those maybe they have some of the same roots. Oh, I didn't mean to say root like it's just by chance. Okay. So, what do we have? This is important. 2 real roots. Maybe you want to write beside here. This greater than 0 means the discriminant is positive. We have exactly 1 root right beside here when it's 0, and we have no roots when it's negative. And with that introduction, we can now go to example 1 and see what kind of questions are discriminant questions and how to, well, like there's hints in questions telling you, hey, you should use this kind of idea. So in this question, without solving, determine whether the equation has, and whenever equation talks about the number of roots, it's giving you a hint, hey, this is a discriminant question, because the discriminant tells us about how many roots there are. This is asking Does it have 1, 2, or no roots? So it's a discriminant question. And our discriminant is b squared minus 4ac. And if we calculate that, well, negative 6 is b, so that'd be negative 6 squared minus 4, a is 9, and c is 1. First of all, we have to notice that it was sure nice that this was already in the right form. Sometimes you have to rearrange it so that it's in the ax squared plus bx plus c equals 0 form. This one was already in that right form. So I'm going to get 36 minus 36, which is 0. What does that tell us? How many roots? And think about it. Here's your quadratic formula. Negative b plus or minus. We just figured out this part right there. That's what we're doing. We're figuring that part out of the quadratic equation. And if you add or subtract 0, you're just going to get one answer. So we can say to this one root. Now, I sometimes find these questions a little bit, like they say, without solving. Like, you could solve it and find the answer that way too, right? You could solve it, find out there's one answer, and go, there's one answer. And I don't think that would be a bad thing. In fact, it tells you more information. It tells you there's one answer, and you've actually found it. But sometimes you'll see in the textbooks or on quizzes and stuff, they like to say, ooh, do you really know how to use the discriminant? We'll say, you're not allowed to solve, but you still have to tell me if this has 1, 0, or 2 roots. And again, it's this part inside the square root of our quadratic formula that tells us that. Because if we have 0 in there, we're only going to have one answer. If it's negative, it's not possible. That's easy. Then there's no answers. And if it's a positive number, you're adding and subtracting something, you're going to get 2 answers. Okay, I'm going to give you the questions on this one, and then we're going to do example 2 right away. 4, 5, 7, and 12. So circle 4, 5, 7, and 12.